In this video we look at pulleys and Newton's laws. So there are two masses. The mass here is 2m, here it's 3m. They are connected by a single, continuous, light, inextensible string. It's light, so the mass of the string can be assumed to be 0, and it's inextensible, so it's not going to stretch. So we can say that the tension in the string throughout is the same. Clearly this is a larger mass than this, so we're going to expect this mass to fall downwards and this one to go upwards. So we will get the same acceleration in terms of magnitude, but in opposite directions. This one accelerates up, this one accelerates down. The pulley is smooth, so there is no friction on the pulley. We cannot treat this system as connected particles because they're not moving in the same direction. This is moving upwards and this is moving downwards, so we can't do that. So when problem solving, we need to split this into the left hand side for this mass, its forces and acceleration, and the right hand side for this mass, its forces and acceleration. What would be common to both systems will be the magnitude of the tension for both sides. That will be the same, and even though the acceleration vectors are pointing in different directions, the magnitude of the acceleration here and here will be the same, but we do need to do these separately from each other. So for the left hand side, Newton's second law, F equals ma, this system is going to accelerate upwards. So if I take the upwards direction as positive, so T minus 2mg, the resultant force, is equal to this mass times this acceleration. And then separately the 3m mass, which is going to accelerate downwards, so I'm going to take the downwards direction as positive this time. So the resultant force here is 3mg minus t, there, equals the mass times the acceleration. So we have this equation, and we have this equation, which we can solve simultaneously. So if I add the two equations together, the t and the minus t will cancel, and then we can cancel out the m's, so the acceleration is equal to g over 5, 1.96 meters per second squared. So to work out the tension in the string, if I take this equation and I substitute in the value of a into here, like so, we get the tension as 12/5 mg newtons. This is the exact value of the tension. Now you can multiply the 12/5 by 9.8 for g, but we don't know the value of m, so we have to leave our tension force in terms of m. So what's the force exerted on the pulley? Well, we can see it's this tension plus this one, so it's 2t, and we know what t is, so we have the tension in the pulley in terms of m and g. So 24/5 mg newtons. Now remember that the acceleration was a constant, so Suvat formulae can be used. So the distance moved in 4 seconds. So we're after s. Initially the system was at rest. We don't need the final velocity. We have the acceleration, that's the exact value of the acceleration, and t is equal to 4. So we need a Suvat formula that doesn't have v in there. So this one, substitute the values in, 15.68 meters.